Hey guys, we're going to go over related rates. Okay, this is going to be note card 46, and we have this framework that I would like for you guys to follow. Okay, so in related rates, what we're going to be doing is we're going to be also, I would like for you guys to be drawing some diagrams. Once you draw the diagrams, I want you guys to list out find, when, and given, because that's going to be useful information for you guys to know, and also want you guys to write down the related equation. So from there, you're going to find the derivative of the relating equation, and then you're going to substitute the given, when, and solve for the find. And this will start making some sense because I'll go over every step with this problem, okay? So it says here, the top of the ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall, okay? So here's what you guys need to do. We're first going to go ahead and draw the diagram, okay? So this is the wall, this is the floor, and we have a ladder that's 25 feet long. Okay? And what they're saying is that it's sliding down the vertical wall, so it's sliding down this way, 3 feet per minute, and since the distance is getting smaller, that's going to be a negative distance, okay? I'm sorry, negative rate. It also says when the top of the ladder is 7 feet, so let's say for instance once it hits this portion here when it's 7 feet from the ground, what is the rate of change between the bottom of the ladder and the wall? So once it hits here, what is the rate of this portion here? Okay. All right. So it says here to put a find, to figure out your find. So we just did our first. We drew the diagram. We're gonna do the find. We're gonna do the when, and then we're gonna figure out the given. Okay. We're also gonna figure out a relating equation in a minute. Relating equation. Okay. So the find. What are we trying to find? We're trying to find the rate at which this is moving exactly when this is 7 feet. So I'm going to denote this as x. Okay? So if I want to know the rate of that, I'm going to put dx dt because it's with respect to time. Okay? When is this happening? This is happening when something is 7 feet, when the top of the ladder is 7 feet from the ground. So if I have this as y, all this represents y. I want to know whenever y is equal to 7 feet, okay, I want to know the rate when y is equal to 7 feet. What's given? All right, what else is given? The rate itself is given. This is given. So that's dy dx because that's a vertical distance, and that's a rate, so it's dy dt, sorry, dt. And that's equal to negative 3 feet per minute, okay? All right, so now the relating equation. So we have to relate all these sides. It's a right triangle, so I'm going to do the Pythagorean theorem, x squared plus y squared is equal to 25 squared, okay? And this is the Pythagorean theorem, so we have that. All right, so now what we need to do is we need to figure out the derivative of this. So the derivative of this is dx, and then dx dt, because everything was with respect to time, plus 2y dy dt, and then the derivative of that is 0, okay? So here's the thing. I'm trying to figure out this, so that should be the unknown. I shouldn't know what that is because that's what I'm trying to solve for. The y is already given to me, so I can substitute that in. I know that the rate, it's negative 3, so I can substitute that in. The only thing is I don't know what the x value is when y is 7, okay? So what I'm going to do is I'm going to do as a little side note and use this Pythagorean theorem to figure that out. So x squared plus 7 squared is equal to 625, because 25 squared is 625. This is 49, so I'm going to take away 49 from both sides. I get x squared is equal to 576. So x is equal to plus or minus 24, but we only need the positive because we're talking about measurements. So I know now I can substitute 24 in here. Okay, so I'm going to do 2 times 24 dx dt plus 2 times 7, because that's my y, it's 7. dy dt is negative 3. Okay, so now I have enough information. I can do 48 dx dt, and then 2 times 7 is 21, and then 21 times negative 3 is negative 63. Okay, and then let me see. So 20. I'm sorry. This is actually 14. Okay, so 14 times 3 is equal to 14 times 3 is equal to 42. So this is equal to negative 42 is equal to 0. And then I'm going to go ahead and solve for dx dt here. I'm going to do a little shortcut. If I move this over here, it becomes positive. Divide, I get a 48. And reduce it by 6. So this is going to be 6 over 7. Actually, you know what? This divided by 6 is 7 over 8. Okay, so this is 7/8. So we found the rate. Okay, so whenever the y value is 7 feet, my rate at which the bottom of the ladder is moving away from the wall is 7 feet per 8 minutes. Okay, so I need to put my units here. So 7 feet per 8 minutes. Okay.